Hello everybody, myself Suraj Rathi. I am presenting you my team Psynova, working on a problem statement MAITRI, dealing with problems arriving for astronauts in their space missions regarding their mental and physical health. Astronauts not only face physical challenges but also serious mental strain, long isolations, stress, fatigue, sleep cycle imbalance and loneliness. Current support systems depends on Earth, which often respond too late. Our solution MAITRI is an AI companion designed to protect astronauts' mental health and physical in real time, even during deep space missions. I am introducing my team, explaining our topics as proposed solution by Sania Kadam, technical approach by Sahil Kadam, feasibility and viability by Mithali Mali, impacts and benefits by Shruti, and resource and references by Alok Kadam.
I am Sanika Kadam, introducing you to our proposed solution, MAITRI. Imagine being millions of kilometers from an Earth, isolated for a month, no doctor, no family, no friend, just you, your crew, and the worst silence in a space. Who takes care for an astronaut's health? Astronaut faces a lot of problems and challenges during the space mission, like sleep disruption, radiation exposure, and the intense level of stress. And that's where our idea comes in. MAITRI, an AI assistant to detect the psychological and physical well-being of an astronaut. It also acts as a coach monitor in a space. It uses microphone and camera to detect the emotional and the stress level of an astronaut. Unlikely other AI system needs internet, MAITRI works completely offline. And due to these offline features, astronauts don't need to face usual 20-30 minutes delay for a reply. And continuously monitoring astronauts' health, it's not only protect their health but also increases the overall percentage of success of a mission. How it works? Continuously monitoring, MAITRI analyzes an astronaut's voice, facial expressions and the behavior patterns to detect earlier signs of stress, fatigue or health risks. Real-time adaptivity compensates. It does not just monitor, it interacts. MAITRI adapts its responses, offering conversations, supports and the personalized interventions based on the astronaut's current state. Predictive alerts. It detects the potential risk. It immediately generates alerts for both the astronauts and the mission control. Ensure the solve before the becoming emergency. Autonomous operation. That most important feature is that MAITRI works even in deep space with communication delay. Unlike traditional systems, it does not wait for Earth responses. It acts instantly and immediately. And the ensure reliability. MAITRI is built as a multimodal AI model that can run offline and stand-alone system, making it perfect for space conditions.
I am Sahil Kadam here. Our technical approach is built around training our own lightweight large language model for astronaut support. We collected and prepared domain-specified dataset like empathic dialogues for astronaut psychological support, and ISRO and NASA's operational transcript for task assistance, and speech emotion data for stage detection of astronauts. These were converted into instruction response pairs and fine-tuned using parametric efficient method like LoRa on a 3 billion model optimized for edge development. Inference integrates multimodal inputs. A vision model detects facial, fatigue, and expressions, while audio pipeline performs speech-to-text and prosody analysis. Diffused state is passed to our trained LLM model, which generates short, adaptive response and critical alerts. This trained LLM model standalone to run offline with limited onboard hardware, ensuring fast response, privacy, and reliability during space missions.
I'm Mithali Mali, and we are going to see detailed explanation of feasibility and viability. So, MAITRI's features: enhancement selection for max psychological reliances and harmony, pre-flight testing with simulated mission scenarios, 24/7 personal intervention for mental health support, self-improvement, AI for enhanced support quality, TRL conversion of fusion of TRL AI and convention architecture, validated blueprint, concept, AI's focus on autonomous crew support, scalable missions designed for long-term autonomous missions, consideration, solve non-negligible human factor risk, unmatched values proposition via holistic data fusion, enhances mission critical sovereignty with predicted maintenance, limited space, data and hardware consumption noted. Final viability, our blueprint is in line with outgoing research like NASA's autonomous crew support system, which proves that this is realistic. The modular design also makes MAITRI scalable for future and long-term missions.
About the impact and benefits about MAITRI. What MAITRI provides. It becomes reliable companion of astronauts, monitoring their mental health 24/7, reducing isolation and alerting mission control before small issue grow into serious problems. That's the potential impact. But MAITRI's value doesn't stop here. Socially, it introduces a new era of AI-driven mental health care. The same technology can later support people on Earth in high stress level jobs, doctors, soldiers, pilots, etc. And at the same time, it showcases India's leadership in advanced space innovation. Economically, it saves over 50 crore per missions by preventing costly delays and errors, and by reducing stress-related mistakes by nearly 40%. This makes space programs more efficient and sustainable. And from an environmental perspective, smoother missions mean fewer wasted resources, less energy consumption, and more responsible use of space infrastructure. So, MAITRI is not just an AI tool, it is a guardian for astronauts, a cost saver for the nation, a source of pride socially, and a step towards sustainable for our future in space.
I am Alam giving you last and most important detail on our last slide of PPT, the research and resources we have used to make our project MAITRI work well. Our offline AI assistant is trained using authentic research data from top space agencies. These references make our system trustworthy and accurate in helping astronauts with well-being and psychology. Human Research Program HRP study on astronauts' health and stress in space. Spaceflight medical logbooks and reports for ISS missions. Research on sleep, workload, and mental well-being of astronauts. Gaganyaan mission astronaut training modules. Health and safety guidelines for Indian astronauts. Psychological preparedness and stress management research. Crew Dragon mission. Health and safety protocols. Real-time astronaut health monitoring reports. Study on astronauts' mental health in Kibo module of ISS. Psychological reliance and teamwork experiment. Behavioral health experiment. Sleep cycle and workload management studies. We collected this all information from official logbooks, manuals, research papers, and other datasets. This ensures astronauts get scientifically correct support from stress, mental health, and physical well-being. This is our brief explanation for MAITRI project. Thank you for giving us valuable time.
Hello, I am Suraj Rathi, presenting you MAITRI, an AI assistant. It's a 60% built prototype and it runs completely offline with a very low latency. So, here we go. First, we have to give microphone and camera access to it.
Good day, Commander. How are you feeling today? Initial analysis confirms a stable emotional state, Commander. Is there anything specific you'd like to discuss or monitor today?
I'm feeling good. I have a few questions regarding you. First, summarize my current physical and mental health using all your sensors.
Based on current data, your heart rate is stable at 72 BPM, speech sentiment analysis indicates a low stress level, and sleep quality index is consistent with previous norms. Overall, your condition is stable. Would you like a more detailed report, Commander?
Yes, please.
Physical indicators show optimal hydration and muscle tone, while mental metrics indicate a focus level of 85% and mood stability at 92%. Would you like recommendations based on these metrics, Commander?
What learning models do you use to adapt my behavioral over time?
I employ a reinforcement learning loop with contextual reward functions, learning from your reactions to stabilize your mood and improve efficiency. When my response stabilizes your mood or improves efficiency, that behavior is reinforced.
If communication with Earth fails, how will you assist me in decision making?
I run an autonomous reasoning engine, trained on emergency protocols, simulating outcomes, and selecting optimal actions for safety and efficiency. Would you like a demonstration of this capability, Commander?
Yes, please.
Understood, Commander. Simulating power conservation mode for the next 12 hours. Reducing lighting by 40% and adjusting life support cycles will lower energy use by 18% with full safety compliance. Is this simulation satisfactory?
Yes. Can you calculate the probability of system failure if temperature rises by 5 degrees?
A temperature increase of 5 degrees would elevate CPU thermal load by 11% and reduce system stability by 6%. A cooling protocol is advised, Commander. Shall I initiate one?
Yes, go for it.
Roger. Task initiated. Cooling protocol activated to stabilize system temperatures. All readings are stable, Commander.
Can you analyze my stress and my mood by using your sensors?
Facial analysis shows no significant stress indicators, Commander. However, I can conduct a voice stress analysis for a more detailed assessment. Would you like to proceed with that analysis?
Yes.
Understood, Commander. Voice analysis indicates normal stress levels. Is there anything else I can assist you with today?
Can you detect my camera and analyze my shirt color?
I can confirm the shirt color is black, Commander. Would you like me to analyze something else?
Very good. Nothing. Thank you.
Acknowledged, Commander. Is there anything else I can help you with at this moment?
Nothing more. Thank you.
Understood, Commander. All systems nominal.